So what's up mga ka-ChE? It's Dale here and I'm back with the part 2 of the chemical reaction engineering. So we're gonna answer the last 20 questions that was remaining, and I really hope that you were satisfied with the 30 problems that I have solved, and now we're going to continue. And stick around for the last part of this video because I have a special shout out for someone. Okay, so yeah, and let's begin. Actually, let's begin. So not delay anymore. So okay. So we left here last time, diba? So we left here last time. We were just talking about CSTRs, diba? CSTRs and PFR, continuously stirred tank reactor and plug flow reactor, and then batch reactor. Okay, so now we're gonna continue to dive into these types of reactors. Okay, so in number 31, so we are asked, so second order in A daw. When CA is 0.03 mol per liter, and the rate is 3 times 10 to the negative 3 liter per mole per S. The rate when CA is 0.015 mol per liter in liter per mole per second is, so we are asked to find the rate, diba? So the rate is RA. So RA, ipinita sa to ah. So we know if it is in second order, if we are following it, if we assume that it's an elementary reaction, okay? So assuming it is an elementary reaction, so we have R is equal to kCa squared, diba? So kung elementary reaction, kaya second order man. So it says that when CA is 0.003, so let's put that here, 0.03 squared, and then the rate is 3 times 10 to the negative 3, diba? So now we can get the K. So K is 10 over 3. We solve for it for K, and now we are asked to get the RA when C is 0.015. So let's we have K here, the 10 over 3, and then we have 0.015 squared here. So RA is 7.5 times 10 to the negative 4 liter per mole per second. Okay, so that's it. So that's letter A. Now for for number 32. So number 32 is just really easy. It's really easy. So first order in A. So we know how the formula of half-life. So we are asked. So we are given the K. So K man siya, and then the half-life. So half-life is just T sub 1/2. So T sub 1/2 is equal to ln2 over K. So it's just really simple. It's formula. So ln2 over 3 times 10 to the negative 3. Okay, and use your calculator. You have 231 seconds. That's letter C. Okay, really easy. So number 33. Number 33 is to have a solution. Let's see if we have a solution here. Okay, so have it. So certain reaction is first order in A, and then in 30 minutes, so A decreases from 0.055 to 0.15. So the time to take for A to decrease from 0.35 to 0.15 mole per liter is, so we are given the choices. Okay, so we are given, so number 33. So this is number 33. Number 33, so we have N final is 0.15, di ba? Mole per liter. So I will not write the units anymore in the next set of data. So 55 mole per liter ang original na amount of the substance. So it's said to us that it is in first order, di ba? So this is what I like because we can use differential equations, di ba? So differential equations is really useful for this. Even it's just the simple ones, so we can use it here. So the rate of decomposition or the rate of reaction of N is proportional to its amount. Okay, so N. So we can do variable separable, di ba? KdP. So we have NO to N. We have 0 to P. So we can the answer, so ln n over NO, then negative KT. So that's how it is. So now let's substitute. Okay, so ln, we have 0.15 here. Okay, mo muna ang final niya concentration, and then we have 0.55 there, and then we have negative K. Dayon the time that given to us is 30 minutes, diba? And then we are to find the next. So 30 minutes na siya. So T is 30 minutes. So we know how the K, so negative K is equal to 0.0433 per minute. Okay, so now we will use this value of K to find the next T, diba? So T, so ako na lang ni siyang i-rearrange. So that's ln n over NO over negative K. Okay, so the second set of data, which is 0.35 and 15, diba? So ln 0.15, diba? And then 0.35. Then just put the answer here of the previous. Then you can get 19.6 minutes. Okay, so that's letter C. That's letter C. Okay, so now we are moving to number 34. So certain reaction has an activation energy of 135 kilojoules per mole. So the rate constant is 0.033 per second at 55 degrees Celsius. So the value of the specific rate constant is at 100 is, so how do we do this? So we have to use the Arrhenius equation. Okay, Arrhenius equation. So you have to use the Arrhenius equation. Let's write the given first. So EA is 125 kilojoules per mole, or 125,000 joules per mole. Diba? So given sa ato is 0.033 per second, and this is a temperature na 55 degrees Celsius or 328 Kelvin, diba? K2 muna gipangita. So this is what we are asked of us. Okay, so we have this at 100 degrees Celsius or 373 Kelvin. Diba? So we have to use our Arrhenius equation, and I've shown you in the last video how you can find the K2, diba? Using this equation. So ln K2 K1 then negative EA R then 1 over T2 T1. Okay, so in this equation, we can use this to find the K2. So just plug and play. So put the values here. This is K1 and then negative 125,000 joules man, and R, use this katong R that is in your calculator, 8.314. Okay, then 373 minus 328. Okay, so you can get K2 shift solve in your calculator, 8.32 per second. Okay, that's really easy, and that's letter D. Okay, that's letter D. So let's move on to the next problem. So certain first order reaction has a specific rate of constant of 4.27 times 10 to the negative 3. So that's the letter K, and then at 25 degrees Celsius, so 198 K. So so K2 at 80 degrees Celsius, diba? The energy of activation, so activation energy in kJ per mole is, so ang what we're finding now is the activation energies, so the EA, diba? So EA na siya. So let's use this equation we have on Arrhenius equation to find our EA. Okay, so let's do that. We have number 35 here. So let's write our given first. That's 4.27 times 10 to the negative 3 per second, and that's at 25 degrees Celsius or 298 Kelvin, diba? And K2 is 7.35 times 10 to the negative 2 per second. This is at 80 degrees Celsius or 353 Kelvin. Okay, so let's use this equation. You get negative EA R T2 T1. Okay, so substitute 7.35 times 10 to the negative 2 over 4.27 times 10 to the negative 3. Ayon, EA, just leave it blank. That is the required. R, just use the value in your calculator. Shift constant 27. Okay, so you have 353 here and then 298. Shift solve to find EA. You have 45.2 kilojoules per mole na siya. Okay, so that's it. That's the answer. So we have letter B. Then for letter number 36, so the third order gas phase reaction. The third order gas phase reaction siya. Okay, so has a specific reaction rate of AC, so 2.65 times 10 to the 4 L² per mol² per S at 30 degrees Celsius and 1 atm. So the value of Kp in mole per liter per atm³ per second is, so we are finding the Kp. Okay, so Kc and Kp are different. So in number 36, so diba, Kc and Kp are different. So Kp is not equal to Kc. What is the formula that relates to them? So Kp is the specific rate constant in the gaseous reaction using partial pressures as the unit of concentration. But C is using mole per liter as the unit of concentration. So how do you switch between the two? Okay, so you can use actually this formula. So this is introduced back in the general inorganic chemistry calculations. So there are really many calculations there. So this, say, R is the universal gas constant. If we will use the another value of that, then T is temperature in Kelvin. Then delta N is the change in number of moles. Okay, so the change number of moles. So change number of moles. The change of number of moles, actually, diba, that is negative. If we are being really strict about it, it's the number of moles in the product minus the number of moles in the reactant. So that's 3, diba? 1, then 2. So 3. So 2 minus 3 is equal to negative 1. Pero, we can't put negative 1 there because what is asked of us is ang iyahang unit is naay 3, diba? Naay 3, naay cube. So it follows that our n that we should put there is negative 3. Okay? So we can make sense of that in the units later. So Kp, so we have Kc here. Kc 2.65 times 10 to the 4th. Ngayon, L² mol²-s times ini nga value ako ang gusto ipagamit because we are dealing with ATM, liters and ATM, ba? L-atm, Kelvin and mol times the temperature, which is 30 degrees Celsius or 303 Kelvin, and raise that to negative 3. Okay, so you will see that atmospheres will gain the negative 3 na exponent, but if imo siyang i-reciprocal, it ends up in the bottom, and the sign of the exponent is not negative anymore, diba? So if you get this in your calculator, you have 1.724 mole per liter per atm³/s. Okay, so that matches here. 36 is letter A. Diba? Okay, so let's continue to number 37. So number 37, it's a bit long, should I say? But it's manageable, okay? So it's manageable. Number 37, the isothermal irreversible aqueous phase reaction. So we have here the reaction, and then we have the temperature, 100 degrees Fahrenheit, obeys. So we are also given the rate equation, and also the K, and we have the volume of the reactor. So straight tank reactor with an aqueous feed of 2,000 feet cube or cubic feet per hour. So the outlet concentration of E and the inlet concentration of A and B are both 0.25. So we are asked for the outlet concentration of E, so CE. So CE ang pinapahanap sa atin. If the inlet concentration of A and B are both 0.25 pound mole per cubic feet is, so yan, CE yung pinapahanap sa atin. So we have to list the givens first. Let's go to the next page, next slide. We have RE, K, Ca, then Cb, diba? Then we are also given the K. Stick with me, guys, because this is a really fun problem. So we have 1,000 cubic feet, and then we have the volumetric flow rate. So we have, let's just name as that as VO cursive. Okay, so we have 2,000 cubic feet per hour. Okay, so we have also the initial concentrations of B. So we have CaO, inlet concentration. So CaO and CbO are 0.25 pound mole per cubic feet. Okay, so we are tasked to find Ca. Yan. So let's draw the system. So because we are this is an stirred tank reactor. Stirred tank reactors meaning this is a CSTR. So yan, let's draw. And then we have here the volumetric flow rate of 2,000 cubic feet per hour. And then we have the volume of 1,000 cubic feet. Then we are tasked to find CE. So yeah, as you can see, Ca and Cb are actually similar, diba? Similar in concentration. So we can simplify our formula, diba? So imbes nga Ca, Cb, so we can simplify it to just Ca squared. Okay? So in terms of conversion, so let's transform that to in terms of conversion. So Ca is actually CaO 1 minus Ca. That's the conversion in terms of conversion equation. So let's substitute that here. So Re, K, so cow squared minus 1 minus XA squared. Okay, so and we have this equation that we derived from the last video, this equation, diba? So that is tau is equal to CaCb negative R. Let's just put Re here because we are getting Re here, diba? So we can also write it this way, diba? Tau. And don't forget that tau is equal to the volume over volumetric flow rate. Okay? Yan. So let's substitute these two. Diba? So we have cow. So let's equate. Let's equate these two. So cow squared 1 minus XA. Diba? And then you can cancel like terms here, and we are left with something. So this is squared di. So let's move all of the excess to the other side, and we have tau K cow. Okay, so and also we know that tau is the volume over volumetric flow rate, or the residence time, cow. Okay, so now we have to substitute. Okay, substitute. Let's substitute all that we know. So actually we're finding for the conversion here ion V. So we have 1,000 na volume over 2,000 na volumetric flow rate. So times then K, we have 15 15, and then cow, we have 0.25. Get the solve to find XA. You will get 0.4892. Okay, and then CE, it's just the because we are finding the CE, diba? It's just yeah. Okay, so CE is equal to 0.25. Ngayon 0.4892. Okay, so 0.1223 pound mole per cubic feet. Okay, that's it. That's how you find the CE, diba? And that's letter C. Okay, so let's move on to the next. This is really actually a difficult, but it's fun. Also, just like number 37, so we have reaction represented by A uses B, and it is to be conducted in a controlled tank reactor. So CSTR gihapon. The scheme of the iteration is shown in the diagram. So the reaction is first order with the established rate of R is equal to 2C pound mole per feet per hour. So the feed FO is to be 100 cubic feet per hour at a concentration of 1 pound mole per cubic feet. So the product removed contains 50 pound mole per hour of unreacted A at steady state conditions. The hold-up time is 15 minutes. The reactor volume in cubic feet will be, so we are to find the V, diba? So we are to find the V, ini V. So don't let this fool you in this one, diba? So FO we have 100, so naana ang kuan. Then CA is yan 1, CAO. Then pretty much F3 CA2 is 50. So pretty much ilan ang gibutang diri ang mga given. Okay? So the one crucial na understanding here is what is the conversion. Okay? So conversion, di ba? Conversion is the X, di ba? X conversion. XA. What is XA? So one crucial understanding here is that you can get this based on this statement, di ba? What went in is 100, di ba? So tama lang ha. Ang isulod is 100 cubic feet per hour. Then ang iyahang concentration is 1 pound mole per cubic feet, diba? So ang sulod is 100 pound mole per hour, diba? Yung pumasok, okay? And then yung lumabas ay 50 pound mole per hour na unreacted A. So meaning, diba, half lang yung na-convert. So meaning, the XA is 0.5. Okay? So that's how I made sense of this when I was solving it, because it really has no use if we don't have common sense in this problem. Okay? So let's use the equation that we have derived from the first video for the CSTR, kCa over tau. Diba? So tau, we know tau if we transpose, diba? We have V over the volumetric flow rate, which is FO, kini 100, diba? And then we have kCa And then we have 2C. 2C is actually 2CA here. Diba? RA na, 2CA. So 2CA. And then if we went further, so replace this with the in terms of conversion, so we have 2CaO 1 minus XA, diba? Then substitute CaO and CaO is actually 1, diba? And you can also cancel that. And then we have V, and then VO we have 100, diba? 100 cubic feet per hour. And then we have 0.5 nga XA. Then we have 2 here, and then 1 minus 0.5, diba? And then 0.5 over 0.5 is just 1. So matabo is 100 divided by 2, and that is 50 cubic feet. Letter A. And that's also the answer in the answer key of the book that I am using. Okay, so that's it. Yeah, it's really easy. Let's move on to number 39. So number 39 has two items, which is 39A and 39B. Now for the reaction A produces B and then B produces C. Both of the K values are equal. Okay, the initial concentration of both B and C is 0.5 pound mole per cubic feet, and CaO is 2.5 pound mole per cubic feet. So the time at which the concentration of B is maximum is, and also the number 39, the size of the reactor so that B is produced at an average rate of 300 moles per hour, assuming that the reaction time per batch is 1 hour and the time of cleaning and dumping is 30 minutes. So we are to find the volume of the reactor. Okay, CSTR gapon ni sila, guys. So let's solve this. Okay, so A, B, C. So K1, K2, and then we have K1, K2, so for 0.35 per hour. Okay, so we have CBO and CCO of 0.5 pound mole per feet, and then CaO is equal to 2.5 pound mole per cubic feet. Okay, that's concentration. We're asked to find Tmax when Cb is at maximum. Okay, so we're to find the time at which Cb is maximum. Okay, and then how do we find this? The reviewer gave us an equation. Okay, and they are really generous to give us this equation, because I can't find this equation anywhere, and they give us this. So CaO minus CBO or CRO, or the intermediate. So this is the intermediate. So the intermediate. Okay, so the intermediate of the reaction, and then divided by the kCal, diba? So equal naman, it does matter which one you use. So we have 2.5, 0.5, 0.35 times 2.5. Okay, and that's equal to 2.3 hours. Okay, that's letter A. Now for number 39B. So 39B is actually given to us also in the in the reviewer, they're really generous to give that to us. So the time is, di ba, 1 hour man to, 1 hour. Time per batch is 1 hour. And the cleaning and dumping is 30 minutes. So we have to account for that. Nga, ang cleaning and dumping is 30 minutes. So just not just the reaction itself. So we have to account for that. That is 1.5 hour. 1.5 hours. Okay? And then we have to find the production of B, di ba? So how many moles of B are being produced actually? Because they say that the number of moles per hour, 300 pound moles per hour produced, di ba? So if na siya 1.5 hours ang time, so you have to find that. So 1.5, so that's 450 moles. So pound moles na siya, guys, pound moles. That is pound moles. And also we are to find, di ba, the CB man, the CB. So CB na karon. And the book also gave us this amazing equation. I hope dili ni siya mogawas sa board exam because I really can't memorize this equation. So yan. Kasi ko kabalo, I don't know also how to derive that because it's the first time I've seen it, and it really took me a long time to solve this because I did not know of this formula, but they gave it, so let's use it. So CB is equal to 1 K, diba? K is 0.35. And guys, don't forget that the CB accounted here is just for the reaction, not the P accounted here in this formula is not just for the not including the 30 minutes na downtime for cleaning, but it's only accounts the 1 hour reaction time in this formula only, but here does not. Okay, we have to include the 1.5 hour. Yep. Yeah. So let's substitute. So K count is 2.5, diba? 2.5, and T, this is what I have said earlier. So the time of the reaction is just 1 hour, not including the cleaning and dumping. So T, then E is 0.35, then 1 plus CBO is 0.5, diba? 0.5. Then E 0.35, then 1. Yan. So CB is equal to 0.9689 pound mole per cubic feet. Yan. So we have to find now the volume of the reactor. That's just divide the number of moles by its concentration. We will have 450 pound mole over 0.9689 pound mole per cubic feet. Then we'll find 465 feet. Ako na siyang gi-round up. So cubic feet. That's the I see. Okay. Now let's move on to number 40. So second order reaction involving reactants. So this fun also. I had fun solving this. Initial present at 0.10 mole per liter is found to be 20% complete in 40 minutes. So the reaction temperature is 25 degrees Celsius and 40% complete in 35 minutes when the reaction temperature is 50 degrees Celsius. So the activation energy for this reaction, so EA na po ang ipangita sa ito. So, and also in calories per gram mole, pag yun, no? So yeah, calories ang ipangita sa atin. So Ang saya-saya nito. Okay? So, first, what do we need to use? Diba? So, obviously, because we are asked for the EA, the activation energy, so we must use the activation energy, the Arrhenius equation. The Arrhenius equation, this is found in your Paris. It's P negative EA RT. Okay? And then, if you want to find the, di ba, makatong mga K2 o K, this is another form. So, EA 1 over T2 minus 1 over T1. Okay? And then, the R that we will be using here is not the R that is in your calculator. So, we have to find it in the Paris. So, in the Paris, katong may calories nga kuan, calories nga unit. So, 1.98 diba? 1.98. Yeah, 1.9872 calories per Kelvin per mole. So that's what we'll use later. Okay? So we are missing, di ba, kini missing taani, and missing taani nga mga kwan. We have the temperatures, we have the R, but missing taani tulo ka mga variables. So EA is what we are we are finding, but K2 and K1 are missing. But we can obtain that from the ng mga kana ng mga information, diba? So let's list that. So ngun sa kuan, ngun sa first nga first condition, we have diba 20% done daw. So 20% ang conversion. Then T1 is 40 minutes. It's done in 40 minutes, and then the temperature 1 is 25 degrees Celsius or 298 Kelvin. Diba? And then for X2, it's 40% complete. So 0.40 na ito ang conversion. Diba? So T2, we have T2 35 minutes. This is in 35 minutes. T2 is equal to 50 degrees Celsius or 323 Kelvin. Yan. Then we are asked to find the EA. And then we are also given the initial concentration of 0.10 mole per liter. Yan. So it's also said to us that it's in second order, diba? Second order reaction. Second order reaction, let's use our differential equation powers. So CA squared. Yeah, that's I derived this in the last video, diba? Derived this in the last video. You have here so CA, so dCA or CA squared. So you have CaO here, then CA, then dayon you have negative K dt. So you have to integrate, and then we have to finally we have this. So ako na ibalhin dito speakas ang kuan ang negative sign so that it will be dili siya kat sa mata. Okay? So let's up muna ni siya ang equation nga gamiton to get the K, diba? So in the first condition, so x1, so we have A. So A in the first one, so A1, nun siya it is 20% done, di ba? So meaning, how much is left? Kung 20% ang na-convert, so how much is left na unconverted? So that means, na 0.8 na nabilin, di ba? 0.8 dayon 0.1 nga initial concentration ng CEO. So you can get that's 0.08 mol per liter. And then it's 40 minutes, diba? So it's 40 minutes. So let's substitute it here. So we have 1 over 0.08 minus 1 over 0.1, diba? Nakuha initial concentration. So we have Ca man then CaO man na. So yeah, we have K3 K dayon T1 is equal to 40, diba? And then if you get the K1, so first one it is 0.0625 ang ihang units. Okay? That's also for the second one, for the second condition, di ba ang A2 CA2 is just, di ba, 40 man. So meaning ang nabilin 60%. So we have a 0.1 also, and then this 0.06, di ba? So I'm speeding through here. Basically the same regular kung kita sa inyo ha, and that is 35 mani 35. This is K2 to have 4 over 21. So this is a kuan nalahi nga in fraction form yung units niya, and then we can substitute that here na already, diba? So ln, you have 4 over 21 here sa K2, and then 0.0625 K1, and then we have negative PAR 1 over 3 to 3 minus 1 over 298. Okay? So don't forget the R nga gamito, R that we will use is kini na value. Dayon EA, you can get 8,526 cal per gram mole. 8,526. And that's letter C. Okay? That's letter C. And then for number 41, number 41 is also a fun. It's actually long, but it's fun also to solve. Okay? Because maputaw gyud yung mutukan. So let's clear this. Let's clear this to make room for number 42. Okay, for number 42, number 41 day, 41. For number 41, you have two, the first condition is you have just a plug flow reactor, and then what is asked of us is we have to hook it up with a CSTR. Okay, so may parallel na siya. And then the reaction is first order reaction with CaO1. So we have that also there, and the conversion is the same at 92%. So we have to solve for that. So first na condition daw hatag sa tuwa is just the PFR alone. Okay, so we have PFR alone, and then we don't know the volume, and yeah. So we are given, di ba? Here, CaO is 1 mole per liter. And then the XA, so XA is at 92% or 0.92. Diba? 0.92. 0.92. So we get the CA there. It's just CaO1 minus XA. We have 1 minus 0.92, 0.08, di ba? Ito ang CA. So we have to find the VO, the volumetric flow rate here, diba? So we have to find the volumetric flow rate. So let's name that VO1. So VO1. Then we have to get the VO1. So for the first order reaction, diba? So let's use this. So ako na ning muna na akong gina Fermi nga gina bato sa inyong equation for first order reaction. So I hope that you get it now. So K, we don't know that yet. V, we don't know also. VO2, we don't know also. VO1 there. VO1, we don't know also. Okay? So, kung ano lang yun, what's best for us is to express it in variables, diba? So, kini siya transpose dito, and kini siya transpose dito. So, can get 0.3959 kV. So, just as is. Okay? For now, the second condition that was asked of us is that we will hook it up with a CSTR. So CSTR isa. And then it's twice down the volume of our current PFR. Okay? So, yan. And then, let's name this VO2. And then, we know VO1 already. Nakini naman. VO1. And then, let's name the overall na volumetric flow rate as VO. Okay? Because mag-split man siya. So, ang VO is just the sum of VO2 and VO1. So, now let's find VO2 diba? For a CSTR. So, for CSTR, ini PFR man ni. So, for PFR. So we have this equation that I keep on throwing at you. Yan. And then I know that it is diba 2B man ni? 2B man siya, 2B over the volumetric flow rate 2. Yan, kini. So we have also a over what is the rate equation for that? So are you given the rate equation? No, you're not given the rate equation, but we know that is first order. So kCaCa, diba? kCa. So if we transform that to in terms of conversion, we have CaO1 minus so this is just the same thing all over again that I have been throwing at you. Okay, so let's simplify. So we have 2B VO2 then this is 0.92, diba? Kini mga naman ni sila cancel kami nga K, we don't know, 0.08. Yan. And then we will have VO2 equal to 4 over 23 kV. Okay? So, yan. We simplify. So, we now have to find VO, diba? VO is equal to VO1 plus VO2. That is the new volumetric flow rate. So, we have to add 0.3959 kV plus 4.23 kV. Okay? So, you have a 0.5698 kV. Yan. So, what is asked of us is the increase in the capacity. Diba? Increase in the capacity because we know that the the volumetric flow rate now is much bigger now that we now hooked it up with a CSTR twice the volume of our PFR, diba? So we have to find the percent increase in the capacity. Okay, so we have 0.5698 minus 0.3959 over, I'm just removing the kVs here para di na ito isulat. Yan. And then times 100. So multiply that with 100, you can get 43.92% increase. That's the A. Okay, so that's it. Let's move on to the number 42. So for a most efficient use of the given set of reactors, how would you arrange the following series in series? So large mixed flow or the large CSTR, dako ba ka CSTR? The gamay nga CSTR, small mixed flow, and a plug flow reactor for N greater than 0 order of reaction. So meaning first order, second order, third order. So what is the most efficient that you can use? Okay, so I'm gonna throw at you a Levenspiel plot. So Levenspiel plot looks like this. Okay, yan. So for a PFR, so PFR siya, PFR yung gusto, that's this is the y-axis, and then this is the x-axis, which is your conversion. So kung muna siya ang imuhang conversion, this area under the curve is the volume of the reactor for a PFR. And then for a CSTR, same hapon, but ang volume niya for the same conversion is ini, the whole kini rectangle. But for PFR, so this is PFR, then CSTR is PFR is just this area under the curve, meaning the volume of the CSTR required is much larger than the PFR required for the same conversion, diba? So it is really wise to use first the plug flow reactor than just using the CSTR right away, because you will be needing a much larger volume if you use the CSTR right away, diba? So use the PFR muna, PFR, and then sunod para efficient ang use mo volume, use the small first, and then next use the large first, large later. Okay, so now we can this is actually the answer, the PFR small then large. Yeah, and then for number 43, so number 43, the three parallel branches, so parallel branches of plug flow reactors na siya, guys. So branch A, so you have to draw that later, and then branch B, you also have to draw that, and then BC, yan. So if the total flow rate is 100 liters per minute, what is the residence time of this BC2 in minutes? Okay, so we have to draw this. So I have to draw this so you will see the beauty of this. So we'll have 43. Oh, sa answer ani. So we have this is the series, PFR in series. So forgive my drawing. Okay, and then we have the third. We have here. Yeah. Okay, so Okay, so this is branch A. So branch A, di ba? So BA1 is equal to 10 liters. So BA2, 15 liters. So BA3, 20 liters. Diba? VB1, so branch B, this is 5 liters. VB2, this is 25 liters. Diba? VC1, 10 liters. And VC2, 40 liters. Okay, so muna yung gipangita sa 2 residence time. So TC2. Okay, how do we find that? So we have to, and then we are also given the total volumetric flow rate of 100 liters per minute, ba? Per minute. And then we have here the VO1, VO2, and VO3. So we know that the VO1, VO2, and VO3 is just the constituents, or it's just the part of the whole, diba? So the whole flow rate is 100 liters per minute. But because of this configuration, we have to consider that the total residence time is similar to the individual PFR residence time. Okay? So kung the whole because of this arrangement, so the whole na kung na ipakita sa inyo so ang akong pasabot, so TO, so which is the whole residence time is equal to the residence time of the branches also. Okay, so that's TO1, tau 02, and tau 03. Okay, that makes our life easier actually, because what we now have to find is just the TO, and that's also this TO here. This TO here is actually equal to the TC2 here. Does it make sense? Because it is equal to the TO2 here. This equal to the TC2 here. Yeah, so it's actually confusing, but it makes our life easier. So TO, so V total, which is V total, volume total over VO. Add. Yan. So V total, if you add this V 10 plus 15 plus 20 plus 25, and i-add nyo na siya, we will get 125 liters, and then divide that by the volumetric flow rate na total, you have 1.25 minutes. Yan. And then the answer is letter A, and it's also the answer in the reviewer. And so jackpot. Okay, for number 44, I explained this to you earlier, that the volume of the PFR, diba? The volume of the PFR at the same conversion is less than the volume of the CSTR at the same conversion. Okay, so always gina siya at the same conversion, the volume of the PFR is less than the volume of the mixed flow reactor. That's letter C. Yeah. Number 45 is the gas phase reaction 2A plus B to R. Produces R, it starts with 40% of A and 30% of B and 30% inerts. Okay, so the reaction proceeds in a CSTR with CaO 0.5 moles per liter, and then the tau, the residence time, is 15 minutes. If the final concentration of A is 0.10 moles per liter, the percent conversion will be yan. So this is different, and this is also the hardest question in the batch, because it deals with gas phase reaction. But if you know the formula, and then you know how to solve this, so it's really easy. But what makes this our life harder? Because of the gas phase. Because gas phase is not the volume of throughout, for example. Yan. So dili, There's a volume of the reactor. The volume here is not actually the equal volume all throughout. So meaning this is not a constant volume, it's a variable volume. Variable volume. Okay, so we have to find now a formula for a variable volume na CSTR. So I was really finding it. So nagbalik ko sa ang textbook, which is the Essentials of Chemical Reaction Engineering by ft³-hr. Diba? And then I found this equation there. So the volume is equal to VO plus epsilon x, then PO, P, at P, then PO. Okay, this is equation 4-23 in ft²-hr. Okay, so since we are not given the pressures or value of pressure and temperature, so we can assume that this is equal, diba? So equal na siya. Because P, kung na lang siya equal pressure loss if you are dealing with catalyst ng mga reaction, diba? So you will use the ergon equation. So mag-fluidization sa daan eh. And then T and TO, we assume that it is isothermal because there are temperature really plays a big part in this reaction. But now we will assume that it's isothermal in this case. Okay, so we'll just have to use this part. So V is equal to the volumetric flow rate plus times the 1 plus PA. So one note that you have to consider is that EA and XA, we are finding really we are using the species that is the limiting reactant. The limiting reactant species because you can't use the excess reactant species. And we are also given the hint of the the limiting reactant because you're given this CaO, diba? You're given that. So we are to use the CaO. Okay, so we have to plug in now. And then what is it? Epsilon. So epsilon is equal to yaw dion delta. So YAO is actually the concentration of A. Begin, diba? Concentration, you have 40% down, 40%, so 0.4. And kini delta gamay delta, so it's actually a formula niya is dA over plus CA over A minus B over A times 1. Okay, so that's just referring to the stoichiometric coefficients. So stoichiometric coefficients nag-divide sa stoichiometric coefficients sa A. Okay, so we have here 2A plus B minus R. So if we write that, divide that to 1/2 B ngayon 1/2 R. So meaning ang atoang delta is we have 1/2 minus 1/2 minus 1. Okay, and then finish siya, then we have negative 0.4. Okay, yan. So we also know that Ca, diba Ca is concentration, it's just equal to the number of moles over the volume. So this is really useful in our dealings later. So Ca, and then you can also express Na as in terms of conversion, diba? NaO 1 minus Xa. Dayon B, just let's substitute that with kining VO dayon 1 ba plus EXA mo na. So let's substitute. Yan. So, di ba kining NaO then VO, this is just CaO, ba? We are really simplifying here because we don't want complicated equations in our lives. Yan. So Ca, di ba? Kabalo ta CaO, Ca is 0.1, di ba? 0.1 man. 0.1 man kini. Final concentration is Ca. This is Ca. 0.1. And then the initial concentration is 0.5, di ba? 0.5. And then 1 minus Xa over 1 minus 0.4 Xa, diba? And then you can you will get shift solve to get Xa 0.8696 or 86.96%. That's letter B. Okay, that's how we can find it. Now, let's move on to the last 5 numbers, which is really fun to solve. I really had fun with this. So, a liquid feed of pure A, it's treated in 2 reactors of 2 liter volume each and reacts with a rate of 0.05 Ca2 mol per liter per S. So, how do we do that? So, 46 find what feed rate in liters per minute that will give a final outlet concentration of Ca 0.5 mol per liter of 2 CSTRs in series are used. Okay, so 2 CSTRs daw, number 46. So 2 CSTRs. So let's get a picture of what we are solving, diba, in number 46. So number 46, we are hooking up to CSTRs in series. Then 2 liters each din siya, 2 liters. Then we have concentration of 1 mol per liter. And then we are to find the VO. Yan. And then we also know that the final concentration here is 0.5 mol per liter. Yan. And we are also given the the rate equation. So Ca2 mol per liter per S. Yan. So the magic equation that I am always throwing at you for a CSTR is ini. Diba? kCa over tau. Now, and then kabalo man ta sa tau, it's just the volume over volumetric flow rate, that is 2 liters over VO. Yan, diba? So at first CSTR, first CSTR sa ta. Analyze na nato ang flow sa first nga CSTR. So the first nga CSTR, you can get this. You can use this equation, diba? Sa dayon 2 here. It's just substitute. Substitute na nako na siya. And then we have yan. VO na siya. And then let's simplify. Simplify nato. So 0.5 CaO. So ako na hindi ini substitute na. So let's substitute na. So 0.05 Ca. Ini. So squared times kCa, ayun, ako yung pasakang B, and natin 2 sa ubos. Okay? Then we can also transform this to so na yung conversion in terms of conversion. Bakaw squared dayon squared pod and kaw sa bo dayon to. So we can cancel siya, and then you can find ito lang i-transpose everything to the side, diba? You can find 0.1. So simplify lang ninyo simplify lang. CaO ayun 1 minus XA. So let's name this XA1 dahil no, kiniki XA1 man. Then XA2. So XA1 para ito maglibog niya. XA2 over XA1. So this is 1, this is also 1. So this save this for later. That's equation 1. So for at CSTR2, muna siya ato ang CSTR2 analysis na sa dato. So gamit gihapon nato ni siya nga kuan nga equation. So negative RA. So for now, parang nga analysis ani is kuan na siya. Na siya XA2 then XA1 minus XA1 na siya. Karon kay right man ang conversion ani like na conversion dari. So kuan hapon this is BO diba then 2. Kind of like this one. Kung lang gidiretso o substitute dayon substitute kiting RA diri, di ba? So 0.05, then let's substitute na directly. So XA2 yan. I don't know. We can know XA2 there. We can know XA2. Diba? XA2 is just we can know this by this equation. So CA2, diba? CA2 is 0.5. And then what is that equal to? That's CaO 1 minus XA2. Diba? So we know that CaO is 1. Diba? So meaning XA2 is 0.5. Yeah. So this is 1 na siya 1. So XA2 is just 0.5. Diba? So that makes our lives easier. So if we substitute that here, so we'll have 0.05 CaO squared 1 minus XA2, then squared dayon we have CaO, we have diba pwede natin na siya ikuan i-substitute. So 0.5 and XA1 dayon we have VO over 2 na. We can replace this with 0.5 and then simplify. To simplify that, we can get 0.025 then 0.5 XA1 is equal to VO. Yan. That's equation 2. So if you equate equation 1 and equation 2, you can get XA1, diba? You can get XA1 and you CaO. Yeah. If you equate them both, diba? So equate them both, we have a 0.025 CaO over 0.5 minus XA1 is equal to 0.1 CaO times 1 minus xA1 over xA1. So shift solve to get xA1. You can get 0.3234. Yeah, and then substitute xA1 to any of this, you can get VO. You can get kung i-substitute mo siya dire, you will have 0.1416 liters per second, or times 60 para may mo siyang minutes, you have 8.49 liters per minute. Yeah. Okay, so that's letter B. Okay, so now we'll have to find number 47. So if two CSTRs are in parallel, so ang kuha niya parallel na po, parallel. So let's delete this. Let's make room for the for number 47. 47. Okay. Number 47. So the setup looks like this. So yan. And yan. So we have VO1 here, we have VO2, and then we have VO, we have CaO, 1 molar, then these are 2 liters siya both. Then Ca here is 0.5, diba? And also kinisad is 0.5 para tong target. Okay, we know that Ca is just CaO, then 1 minus Xa, diba? And then we know that this is 0.5, this is 1, then 1 minus Xa, so Xa is 0.5 here. Yeah, we know that. So for at any CSTR, okay, same mo naman sa sila, times 2 lang dayon from kuha na ng total nga volumetric flow rate, diba? Simple. So the magic equation, the obnoxious equation. So we know T, 2 liters man, then VO1 lang ako. Isa lang ka CSTR. So kini siya dito is transpose. So you have 2 VO1, and then you have sa dayon substitute RA, so 0.05 kana siya, ako na siyang wandaan, ako nang gi-substitute. So substitute dire 0.5 kini 1 kana siya 0.5 gihapon. So you can get VO1 as 0.05 liters per second or 3 liters per minute. And then you get the VO2 also just equal to VO2. So diba, VO, the total is 3 plus 3 is equal to 6. Yan. So number 47 is letter A. So for the last 3 numbers, rapid na kita man. Number 48. So number 48 daw is duha ka parallel nga PFR. 2 parallel PFR. So, ito man. So 2 parallel PFRs. So this is 2 liters gihapon, this is 2 liters gihapon. Same nga sa same ani nga setup. So at any PFR gihapon, So the difference is just not algebraic anymore, but kuha na siya kining differential equation, di ba? So differential equation, so I threw this at you earlier. So don't panic. I threw this at you earlier, so you know how this was derived. So, di ba, ang 1 over a na to is 0.5 and then 1 ni siya. And then, ang k na to, kay itong 0.05 sa kuan, sa na, sa rate equation, 0.05. Dayon, kining t day, this is tau, this is the residence time, which is 2 liters, diba? Then VO1. So, just shift solve to get VO1, you have 0.1 liters per second, or kung duha na, so this is also equal to VO2. So, VO is equal to 0.1 plus 0.1 is equal to 0.2 liters per second, or 12 liters per minute. Yan. Okay, that's letter C. Okay, so number 49. 49 is just one down. PFRs in series. PFRs in series. PFRs in series, which is actually equal to this same lang ilahang kuan, ilahang analysis. So same lagi hapon kay second order man. So ang total nga volume here is 4 liters na, di ba? 2 plus 2. Kay series naman siya, so i-add na to ang volume. So we have 0.5 here, then 1 over 1, then 0.05, then ang ako ang volume karon is 4 liters na. 4 liters, then we have VO. Diba? VO. Okay, VO mandiri. So, shift solve to find VO, still 0.2 liters per second, or 12 liters per minute. Yeah. So that's letter C gihapon. Number 50, CSTR and PFR hooked up in parallel. Okay, so CSTR and PFR hooked up in parallel. So it's just simple. It's really simple. So let's delete this slide. Let's delete the slide. Let's erase all ink in this slide. So yan. So PF so we know that this is CA 0.5 gihapon, so meaning ang iyahang conversion is 0.5 gihapon. Know that already. VO2. So you will expect different volumes here na, di ba? So this is VO. Yeah. And actually this is really simple, di ba? VO1 is just the volume metric flow rate of CSTR. So in the previous calculation, ang isa ani is 3 liters per minute, di ba? 3 liters per minute. So sa CSTR. And then for the PFR, it's just ang isa, di ba? Ang isa lang kabuok. Ang isa lang kabuok ganina is 0.1 liters per second, or 6 liters per minute, di ba? So we add that, you have 9 liters per minute. Yeah. Simple. Letter B. Yeah, so that's it. Diba? So actually that ends our very long na video. Forgive me if I went too long for this video. Really,